Okay, so I have the honor to give some closing remarks. Clearly, it has been a long day, at least for those of you who have been here from early this morning, like me. And if I look at the audience, there's still, I guess, more than 100 people here, which is more than twice what this workshop was originally planned for, and that after a long day. So I think that reflects pretty much that it indeed was an exciting day also. In my mind, this workshop had three goals. For one, a lot of you are not really involved in quantum information science in a deep way. I'm not, many of you are not, so this was a really good introduction, opportunity for an introduction. That's sort of goal number one. Goal number two, for me, is to sort of share the excitements about quantum information science and to showcase what's actually already going on at Stony Brook and Brookhaven sort of in this area. And I think for goals 1 and 2, the workshop was a real success. At least I feel that way, and I hope that many of you do as well. We had 2 fantastic lectures by pioneers in the field, Seth Lloyd and Barry Sanders, and we had 4 sessions that were sort of organized, as I then found out during the day, around the pillars of quantum information science. And, you know, the content gave you sort of an idea of the breadth of what is going on. And with the panels, you got sort of a feel for how many people are actually already involved in this. And I want to sort of go through the 4 pillars and just make one remark. I'm not trying to summarize in any way. So quantum communications. We heard that just around the corner, there's a 10 gigahertz Stony Brook BNL Yale quantum network. Now, I've heard many people say that that's completely unrealistic and impossible. And I want to remind you of a remark that Barry Sanders made during his talk. I don't have the exact words, but I'm sure I have the spirit right. He said that the fun part in this field is that there are many problems known to be impossible to solve, and then someone comes along and finds a way to circumvent them. And it then is certainly someone who has a track record of doing so in the past. So we'll see whether that's impossible. Quantum computation, we saw sort of a glimpse of the power of quantum computation. Quantum simulations has the promise to understand fundamental science with a very different approach. And the last session was about quantum materials and devices, and there's a very clear need for new devices. And actually, in a way, Dima, in his last slide, perfectly summarized the day. And I want to just remind you, progress in quantum information science requires radically new ideas, experts in different fields in science and engineering, and Stony Brook and BNL has everything in place to make an impact. We just need to coordinate it. And that's sort of the third goal in a way, and that is to bring people together, to network, to build momentum, and to forge new collaborations. And in a way, today was a starting point for that, and it's up to you in the audience here to actually follow through, and I very much encourage you to do so. So now, before I formally close this event, I want to mention that this workshop was made possible by the support of Stony Brook's Research Foundation, and I also have to mention the support from the Provost Office. But really, I wanted to point out that this event would not have been possible without the tireless effort of Nina Monk and her team, who actually made this not only come to pass, but also run very smoothly. And I would like you to join me in thanking them. And with that, I formally close this workshop. Thank you.